Hi everybody. So my name is Andy McMahon. I'm machine learning engineering lead at NatWest Group. So I basically lead a team responsible for defining and scaling out best practice in terms of machine learning engineering and MLOps at the bank. So today what I'm going to talk to you about is how we've built a capability that allows us to do enterprise scale MLOps at one of the largest financial institutions in the UK. So we'll just crack on with it. I probably don't need to tell this audience too much about the basics of NatWest, but just some numbers to bear in mind for us. We're quite a large organisation with about 60,000 staff worldwide, mainly based in the UK, India and Poland. We have around 3,000 models already running in the bank. Now, the vast majority of them are credit risk and IRB, etc. models. They are not machine learning models. But the percentage that are machine learning and AI models is continually growing, and that's why MLOps, ML engineering best practice is becoming more and more important for us. We also have around 500 data scientists and data engineers across our data and analytics capability in the bank, so a very large contingent of people focused purely on driving value from data. And all of these people work very hard to support our 19 million customers and the 1 in 4 commercial businesses that bank with us in the UK and Ireland. I won't talk too much about our purpose, but our purpose you can find online, but it spans a lot of important areas around climate, how we support businesses and families to succeed, and how we also provide financial education to help our customers do the best they can with their finances. So that's NatWest in a nutshell. As I said, it's the audience where you probably know a bit about us already. But what you might not know is that over the past few years, we've definitely been wrestling with this question of how to build really scalable and performant machine learning systems. So what I have up on the screen here is one of my favorite diagrams ever, I would say, from a paper called Hidden Technical Debt in Machine Learning Systems, written by some of the engineers from Google in 2015. But I think it still stands true, what it's saying. And what it's basically saying is that when you start considering a machine learning model, so a bit of software, an algorithm that learns by exposure to data in order to solve a predefined task. And then you want to build a software product around that. The key part to bear in mind is that the actual code that does the machine learning piece is only a tiny fraction of the entire solution. So it's this small bit in the middle. So a few years ago when everyone got excited by the promise of data and hired hundreds of data scientists, a lot of them are very much focused on that small black box. ML engineering and MLOps is about how you expand the domain of that to include all of these other pieces that are so important. How do you manage the infrastructure? How do you manage the scheduling and orchestration? How do you manage the integrations with other solutions? How do you manage the data and the serving of data to the ML code? And how do you manage the underlying models and artifacts that support that ML code to do its job? So basically the core of MLOps to me is when you consider this holistic picture rather than just that small black box in the middle. And when we thought a few years ago about how we would start actually making MLOps a reality in the organization, we started writing down some of the main challenges we were facing in our data function, really. And these span across 4 key areas: people, process, data, and technology. So on the people side, we found that although we have a large body, as I mentioned, of very talented people, we were finding it hard to create a consistent language for them to basically get the same level of training, get the right capabilities that they needed to do their job successfully, and also to provide them with the correct operating model to work very efficiently and optimally. So we had a lot of good people, but not necessarily joining up the dots in the right way that we wanted. We'd find as well that when it came to building these very complex systems involving the latest tools, technologies, ideas, process was a major challenge for us. So NatWest has some brands under it, under the group that have been around for hundreds of years, like RBS. So there's a lot of legacy processes in there that just have naturally grown over time and that we still embody and still use today. But we found that if we're trying to be a modern technology company within NatWest, if you like, who's doing these advanced MLOps practices, we're still finding there's lots of manual handovers, there's a lot of governance we have to go through to these traditional risk management and control practices, which are very important, but they are taking a long time for us. And that's leading to a long time to value. So going from idea on a whiteboard through to a production solution is taking a very long time. And that impacts not just morale for the team, but also our customers directly. On the data side, We have a huge amount of data, as I mentioned, 19 million customers, 1 in 4 commercial entities in the UK, tons of data. So data sourcing and data volume is not really the problem. Where we have seen problems historically is data access. So providing a consistent data fabric through which different teams within the bank who want to solve specific problems using data can get access to that data in a timely and repeatable way. It's actually been a major challenge for us. So if we ever build a solution historically that needed data, it would have very complex and costly integrations required. And then finally, underpinning all of this, I would say, and very relevant to this conversation, is technology. So we've again grown up with lots of fragmented and out-of-date environments. I don't think we're the only financial services institution that will experience this problem. We have some technologies there that are very old and very out of date, and people who have the capabilities to manage them successfully aren't necessarily still in the organization. And then we have new tools that we're trying to embody as well. And what we found was, again, the integration, the knitting together of all of these into consistent solution patterns and designs was very costly and complex. So what we set out a few years ago was defining an MLOps vision to try and tackle this. And the idea was, could we modernize our tech stack? So we're using the best of breed components. Could we simplify the access to the data and make it a consistent way of getting in to get that raw material that is used for machine learning products? Could we optimize the governance that we're doing? The risk and control behaviors that we have are extremely important. You'll all know this, working in this area. So it's not something we want to get rid of, but is it something where we can automate some components or perhaps streamline the entire process? And then finally, can we standardize the patterns, those integration solutions, how you package up all of those boxes I showed? Can we standardize it from being more an ad hoc and bespoke endeavor for every project down to something that's very much off the shelf, here's the recipe you're following. And all of that would then underpin faster time to value for our customers, because the idea is we want to go from idea to production, not in a year or 2 years, but in a couple of months. We want to have that drastic a cut down in cycle, because then we'll be able to do more with our data and create more value for our customers. So that's the challenges. And then kind of mapping this out so you can kind of picture where we were about a year and a half ago, 18 months ago, I would say. We started engaging with AWS as a sort of partnership to do a program to basically up our MLOps capability and bring some of that standardization and best of breed technologies that I mentioned. So if we think then at the beginning of that engagement, we mapped ourselves on this MLOps maturity curve, which you can see goes through different stages: the initial experimental phase, the more repeatable phase, the reliable phase where you trust the solutions more, and then finally the enterprise scale phase. And we were very much just past this initial stage gate, I would say. We had some footprint on the cloud, we were on AWS, but we were doing it in our own way. It was very manual still. The promise of kind of the cloud of ultimate scalability and flexibility and everything being amazing wasn't quite manifesting. But we were seeing some of the initial benefits, so that we knew there was something there to build upon. And making that a bit more real, at the beginning of this engagement, we started defining some of the metrics we wanted to move. If we were going to move the needle, how would we know we had successfully moved it? So we wrote down some KPIs for the project, some metrics we were wanting to go after. So I've listed a few of the important ones here. And we tried to make these as simple in terms of language and understanding as possible, because through the journey we were about to go on, we weren't just trying to go faster, but we were trying to do it in a way where we could sell to the teams who were going to use these technologies and capabilities how to do it. So it was key that we were speaking quite plain language everybody understood. So here you can see that when we say we wanted faster delivery of end-to-end solutions, previously it was taking around a year, and that was kind of with a good wind behind you and a bit of luck to go from idea on a whiteboard to a production-ready solution. Get about 5 days to fill in the forms you needed to get access to data, to actually start doing your data science. The ML model route to live, so you've maybe already got the model ready to go, but it actually would still take us 3 to 6 months to spin up the infrastructure, connect it together, get the model through lower environments up to a production-ready environment. If we had environment creation requests, so we're spinning up some of the infrastructure we need for the first time for a project, that was taking longer than 30 days. By the time the request went to a central team, it went through their process, they triaged it, and then they actually actioned the request. More than 30 days just to get just to get started, basically. And then in terms of model execution patterns, already mentioned, although we have an architecture function who was providing guidance as best it could, we still had a lot of very bespoke patterns emerging. So every use case was almost its own kind of Frankensteinian monster of stuff stuck together. And we wanted to reduce that down as well. So these are some of the metrics we want to go after, and that sort of tells you why we were this far left on this curve. So one of the first things we did working with AWS was try and codify some of the key things that would be the most important things to go after and embody through the solution we were trying to build. So ultimately, we wanted to build an MLOps platform. And what we recognized was so important here was basically manifesting the idea of a route to live that is scalable and repeatable. So a route to live is a very common idea in software engineering. It's a bit less common in the data science world, and the idea of MLOps, ML engineering, again, is to bring that to bear. So this diagram here, I won't go through it in detail. This is actually in one of the 4 blog posts we wrote in collaboration with AWS. So if you just Google AWS, NatWest, machine learning, these 4 blogs come up and tell you all the gory details of all the technology we used, which I won't, again, go through now. But one of the first diagrams we have up is about this route to live, because I think this is one of the most important things you can educate machine learning teams on. It's the idea that you want to spin up repeatably and then use a development, test, and production environment, and you want to use that to build the initial solution, to test it as if it's running in live, and then to finally deploy it. And you want the transition between these different environments to be as smooth and automated as possible using things like CI/CD, DevOps practices. So basically by writing that down, we started sort of creating a spine, an anchor through which we could start these sort of communications. Because when you say to different maybe data science teams, we want you to do things more like a software engineer, where do you start? This is where you start. It's a route to live that goes through to production, a scalable and repeatable way. Yep. The next thing that we did with AWS was start really debating and understanding the tools we could use. So being on AWS, no surprise, we were going to use the SageMaker tooling that they have, which is their go-to solution for building machine learning solutions. But the key thing that we wanted to do there was not just say, right, you're in a use case, you have a project you want to build, here's a SageMaker instance and an account to access it. What we wanted to build was a fully fledged architecture, an ecosystem around that, through which you could do all of the key stage points and processes you have to do to build that multi-layered solution that I showed earlier. So here you can see, again, a gory detailed diagram from those blog posts. But the idea here is that SageMaker, these kind of brain pictures, appears in quite a few places. And the idea is each time we're using a slightly different piece of the SageMaker ecosystem to solve a slightly different piece of the problem. So here what we're doing is allowing for the fact that for many different models, we'll have different build, train, validate, and register pipelines and steps. We can all do that within SageMaker, connecting to their model registry. We can then deploy and test in different environments using SageMaker pipelines. So the idea is there's a scalable modular architecture that, although we're quite reliant on the SageMaker tool, we can eventually, and I'll talk about this later, swap in and out certain components if we find, say, a third-party tool that defines best practice a bit better for us. And then the key thing is architecture is only one piece of the puzzle. The next thing is process, which I mentioned before. So we started basically setting out the ideal process we would want, and then we actioned it to make it a reality. So now what happens in NatWest, essentially, is a data scientist or data science team, someone will come to us, the owner of the project will make an initial request, a base set of infrastructure will be created using, say, Terraform and their own infrastructure as code scripts. We will then provision a self-service domain and more infrastructure using AWS Service Catalog. I'll show you what that kind of looks like in a second. But that's essentially a tool for pulling together lots of different infrastructure as code templates, networking configuration, security protocols, etc. And doing that in a repeatable, scalable way, so at the push of a button, you can spin up that entire route to live I mentioned. And then the data science lead goes in through pushing a few buttons that's very clear, creates a new project in SageMaker. The development team then uploads some opinionated templates we've provided. So we've basically tried to understand ahead of time what sort of problems we'd like to solve in the bank and provided basic sort of scaffolding for use cases to action. And then they edit those how they want. They go through their development cycles, ideally in a CI/CD way using the tools that we've provided. That's all part of the platform. And then eventually they execute the route to live. And then they have a fully fledged machine learning solution that covers all those boxes I've mentioned. But the data scientists have only had to think about the key pieces where they're driving value add. We've already done all the heavy lifting in building this platform. So the one key thing I want to draw out for that's a bit of an important strategic decision we had to make was, how are you going to do that not just once, but again and again and again? And what's important there is that we decided to abstract out much of the base solution, architecture and implementation into what we call a shared service account. So basically this acts as a central hub of resources. So the details are kind of like, it's Elastic Container Registry, it's Docker containers, it's Terraform scripts, it's all of these things. It sits in a centralized account such that when the data science team engages with that process I mentioned, they'll create a use case account, but then it'll interface off to this shared account and pull basically the resources it needs from it. And the amazing thing here is that because we have this kind of hub and spoke model for the resourcing, the actual technical resourcing, if we see something wrong or we want to make an augmentation, we can put the change in that shared service account and proliferate it down to all the use cases. So we can have more automated sort of fixes across all of the users of the platform. We then had to try and understand, on the back of the process idea, we had to try and define the different roles we'd want engaging with this platform and how that would map to our security principles and our IAM management, as we call it. So we use IAM policy statements in SageMaker and user profile tags across the whole AWS estate, actually, so that a user can only act as one of these roles at a time, and that creates a quite secure environment. So that helps with those control and risk behaviors I mentioned, while still allowing people to do their jobs. So in general, the sort of lighter pink here is more day-to-day development activities. So you've got a tech lead who can request resources and push the buttons to spin up the domains and infrastructure. The developer, which covers for us a data scientist, a data engineer, any ML engineer. And then a model approver who acts as a touch point between all these processes and our model risk governance, which is a separate set of validations that we have both internally in the bank and occasionally externally if needed. And then there are the more platform-specific roles around support and fix engineers, so that if there's a hot fix required, we can do it, or if there's BAU support activities, that can be done as well. And all of this maps to the principle of least privilege, so that people only have access to the components that they actually need access to in order to protect the infrastructure and protect the bank. So that's what one key part of it looks like. I'll just skip over this, I think, but roughly, it's just to show you that when you go into AWS as a data science lead, it's actually a super smooth user experience. So these things you're seeing here, basically you click one of them and you say push the button, and that spins up all of the stuff I've been mentioning. So it's a very smooth process. Building on that process idea, as a data scientist, these people who are kind of very smart people, but they're used to their ways of working, right? So they're often working what we call notebooks. They'll maybe be working in IDEs and sort of development environments. The SageMaker setup we've got provides all of that out of the box, but we've also added in integrations with on-premise solutions. So you can run from your own NatWest machine where you run in your PyCharm or your JetBrains sort of IDE environment where you develop code. You can do that locally and integrate up to the cloud, so you can push jobs up and do all your classic version control and software engineering best practices as you would normally, but you can still leverage the power of the cloud. And then the final sort of technical point I wanted to cover really was that if you're not happy with some of the components in this platform, or you want to augment it with certain other behaviors and tools, we can do that because everything's built in a modular separation of concerns based concept. So what we found was we wanted to basically augment some of the capabilities we had in the platform with what we call our MLOps Workbench. So this is where we can bring in third-party tools to augment some of the capabilities we've got natively in AWS. So some of the key ones in MLOps are model management. How do you track and version the actual model artifacts that you're training each time? So how do you know version 2 is better than version 1 and swap them out in production? Model monitoring. How do you track the performance of these statistical and machine learning-based models? And then explainability and bias. It's very important, becoming increasingly important for all sorts of reasons, to explain your models and understand that they're not biased towards certain segments of your customer base or against certain people. So that's an important part of this as well. And what we've done is introduce separate tooling here that can all be accessed via REST API calls. So essentially that means you don't have to be actually in the cloud to use these tools. You could again be doing it from any piece of infrastructure in the bank. So even if you're not in the new sort of Starship Enterprise fully fledged MLOps setup, you can still use these solutions to do better MLOps practices. So one example of that is we've recently onboarded a tool called Comet ML, which helps with model management. So this is kind of a competitor, if you like, to AWS's own model registry tool, but we went with Comet. We have a good relationship with them. We understand the capabilities there, and we think that's more appropriate for what we need. And now basically we're onboarding the two separate components of that solution across that dev, test, and production environments. So experiment tracking they provide and the model registry behaviors. And again, we can just slot into these different environments in that route to live that I spun up earlier. So you can see that way we've built the platform provides a consistent backbone that we can just always hook into and always plug into, even when we're bringing on board new tooling. So in a nutshell, what have we sort of delivered? We've delivered lots of things that help us do MLOps at scale. So we've got production-ready ML workflows through some of the stuff I haven't mentioned, like SageMaker pipelines. We've got reduced time to live through the enabled self-service process I've mentioned. We push some buttons and get the capabilities you need. We've got better auditability now because we have inbuilt for every single use case, model performance tracking, model registry behaviors. All of these things that we would have liked people to do before are now basically a core part of the platform. So just by doing data science in NatWest, you now get these capabilities there, so you're more auditable, better explainability and bias reporting. We've also reduced cost and enabled sustainability through the use of managed services. So rather than having on-premise infrastructure, servers, etc., running 24/7 that we barely use, we now only pay for what we need and we only spin up the resources when we need it. So ultimately what we've seen is a drastic reduction in our carbon footprint of our compute, which I'll now I'll talk about in another slide. Some of the other outcomes we've seen is before and after. Sorry for the horrible colours, doesn't come up very well, does it? Before and after, the key point is we had a process before that would take around 40 days to sort of get really started in your ML project. We now get that down to around 7 days. And one of the kind of blowaway moments in this for us was when we recognised that spinning up the core ML environment used to take us around 5 days to put in the request to the central team, have it triaged, actioned. But then even though they were using infrastructure as code, there's still a lot of manual processes that were sort of shifting and lifting, pushing of buttons. Now through the use of our own infrastructure as code templates in Terraform and then the AWS-based projects and service catalog concepts, we've reduced this down to less than 2 hours. So that's absolutely drastic in terms of performance. So rather than waiting 5 days and these data scientists try and find something else useful for them to do, they simply wait 2 hours, they come back and their environment is there pre-packaged and ready to go. So we've shot right up this maturity curve. Some of the key things that I'll call out here in terms of those metrics I mentioned before, we now think that we've got our first few use cases that are coming through this. They've not quite hit the KPI of less than 3 months, but we're now confident that we're going to start tracking against that. So we went from around a year to 3 months. So we've cut it in a quarter from idea to production. The discovery and access to data, which I didn't cover today, but there's a simplified process and access points and boilerplate code for that as part of the SageMaker templates you get. So now 5 days to 1 day. The route to live for the actual ML model, even with testing cycles and all the other governance we have to do, it's went from 3 to 6 months to less than 2 weeks. I've already mentioned the environment creation, say end to end 30 days. You could say the actual key piece is 5 days, but now it's less than 2 hours. And an interesting one for me is we've reduced the number of ways we can do ML drastically. So there's very standardized patterns now. You've got this platform as the core ML black box, if you like, where you do all the stuff inside it your data scientists can do. But then how we integrate that with our other tooling has now become a lot more standardized as well. And I mentioned sustainability. We've seen a lot of benefits in sustainability already. So for an average training run of a machine learning solution, we've got 54% less running time, which translates to 75% less CO2 emissions. So this came about again from that managed services approach where you only pay for and actually consume what you need at the time of running. So it's a lot more ephemeral, things are spun up and then spun down. And this is helping us get towards our targets of having the climate impact of our financing activity by 2030, becoming net zero by 2050. Very final slide, I promise. Oh, well, I've got one more that's a quote. But we've we've recognized as well that although there's a lot of cool technology here, and you can probably detect from the way I'm talking about it, we're quite passionate and excited by it. It's a very small part of getting this actually working in a large organization like NatWest. So one of the main successes of this program has been the spinning up of our adoption and engagement workstream. So this is where we basically have a team solely devoted to selling the benefits of this new platform and engaging with teams who would likely use it and getting them onboarded to it. So basically holding their hand through the first few projects that they do and providing training. So we've trained hundreds of data scientists and engineers. I think we've rolled out something like more than 1,000 training courses from AWS across the organization now. And what we'll do is we'll take them through the process for spinning everything up the first time, engaging, and even take them through all the way through to production with a consultative kind of effort. And then they become champions of the solution for their teams, for their projects. So it becomes this kind of self-propagating positive cycle, if you like. And we always constantly seek community feedback and support. And we're now growing a kind of consistent community. So this helps with that people challenge I mentioned before. People are really excited by the technology they're learning. They're all speaking the same language. So a lot of challenges are now being met. And the positive outcomes of this have been recognized by our Chief Data Analytics Officer, Zach. So Zach Anderson, I'll let you read this. I know there's a lot of words in it, but basically the key things are, he has recognized and said very publicly that what we've done here enables us to deliver at scale, enables us to simplify and embed how we do analytics across the org. We've simplified how we access data, demonstrated that data-driven insights can be delivered faster. So faster time to value is that overarching goal I mentioned. So that's super important here. And ultimately, we're positively impacting our customers. Everything we've done is with our customers in mind. So the fact we've now been able to do that and deliver much more quickly, but also more robustly and scalably is at the heart of what we're trying to do here. So with that, I'll finish and I'll hand over I think we've got 5 minutes left for questions. So thank you so much. Yeah. All right, okay. I was pointing. Sorry.
Hello, can you hear me? I don't know if that's working.
No, I think it's just for the camera. So
I see. Sorry.
I don't think it amplifies that much. Yeah.
You said you've got a separate slide, but you didn't go into it specifically. But how on earth did you get down then from 5 days, which I thought was already good to start with, to be honest, accessing data down to 1 day? How did you do that?
Yeah, okay. So what we've done is as part of that kind of consistent, those templates and the spinning up of the infrastructure I mentioned, what's happening is we're basically setting up the accounts so that they become pre-packaged, if you like, with accesses to our base data lake. So it's a bit of a sleight of hand because if you have specific requests for very protected data, secret data that we call it in the bank, you will have other processes you need to jump through. But essentially the key thing there was understanding what are the basic data products. We already have an enterprise data lake in place, so we know the base data products that most of our use case teams will need access to. The idea is basically trying to pre-package that as much as possible. So that, and then just challenging the whole need for a massive process to go through everything. So just basically saying to the bank, this should be okay, because this is not PII data, this is not, secret data. It should be accessible to all the data scientists and data engineers. So it's a bit of a process challenge and a bit of a technical challenge, but combined, that's basically how we did it. Hope that answers the questions. Yeah.
I'm curious if you can explain how you evaluated different platforms, and for example, the Google Cloud platform and all its components for machine learning. And what was the conscious evaluation that led you to AWS?
Right.
And your conscious awareness of the functionality in the Google Cloud platform compared to this, what you missed out and what you gained, and also if this locks you in, or if you're saying no, it doesn't. It gives you like perfect versatility, so you can connect to anything as you want. Is there a standard that you can say, I want to have this component from here or here? Can you just pick and choose as you want?
Yeah. Gotcha.
And the last question is about, what's the real world benefit? So you say, okay, before the machine learning, what was the effort? How did it improve some kind of metrics in your organization after you introduced it? Is there some kind of measurements before and after?
Okay, yeah, thank you. So in terms of the first question was really around comparing different clouds and how we decided AWS and how we know what we're missing out elsewhere. I would say so. NatWest does have a footprint in all of the 3 major public clouds, so we have some experience across all of them, and we knew roughly what we were getting into with AWS. But what we were very impressed with on AWS was that their new MLOps ecosystem. So I think we're one of the first adopters of this entire end-to-end ecosystem. So the key thing for us was they understood the end-to-end best practices we should adopt and not just the technologies. So we had a very clear idea there that even if we sort of onboarded AWS, got this way of working, and then changed later, we could still keep the best practices and the more process-oriented things. So I think that was very important for us. In terms of what we're missing by other clouds, it's a really good question. I don't think we know. I know there's a lot of people saying, I've heard conversations saying, actually Google might outcompete AWS on specific tooling, and same with Azure. I always bring it back to, and despite having sort of written a technical book on this topic, I always come back to tools that aren't that important almost. It's a secondary consideration. The most important thing is the people you build your teams with, the processes you build out, and then how you sort of communicate that and get that adopted in the organization. So I think if we are missing something, we almost think that we'll take the hit on that to get the clarity of the process, basically. And then in terms of the valuation, we're going through the valuation now. But a lot of those metrics we've seen are through specific actual projects where we're recording the uptick in the KPIs. So we have a lot of tracking for our project management anyway that feeds through to different planning. So now we're just doing that through a lens of, are you using this platform? And we feed that back in. Hope that answers the question. Got one more, quickly.
So thanks for your presentation. What questions did you actually answer? Because for me, from a data science perspective, is what's the question are we trying to solve? So can you give examples of some of the questions that you've asked, and have you been successful in answering those questions, if that makes sense?
Yep. Main question I would say we asked, and just let me know if I'm not exactly answering your question. Main question we were sort of asking at the beginning was, how do we build products with machine learning in them faster? And that was kind of the key driver, right? And then secondary to that was make sure they're secure, make sure they're robust, make sure they're repeatable, make sure they're scalable. But the key question for us was, how do we do this faster? Because we were looking outside at other organizations and they were delivering value very quickly. In my previous organizations I've worked at, we were delivering about 4 times, 5 times, 10 times faster on some projects than we were. And we were sort of saying to ourselves, I don't think we're that bad. We actually have a lot of very talented people in the organization. What are we kind of missing? So the key question was, how do we bring that together to get that faster time to value? And I think we've answered that question. So it relates to the answer to the previous gentleman, was really, it's not just about the right tooling choice, it's more process, the people, and then the system designs you sort of have, so that becomes as standardized as possible. So I think the key question was, how do we go faster?
Well, can you give an example? Sorry. So for like your digital banking journey, what did you improve by using data science? I'm trying to understand.
Oh, okay. So NatWest are a massive organization. So we've employed data science machine learning across financial crime and fraud, detecting different variants of fraud, reducing the amounts of fraud, increasing exit rates of fraudsters. We've also worked on different things in climate change initiatives, so we have better tracking of our different products, the environmental impacts. We've done a lot of good work that's in the public domain on customer lifetime value modeling and modeling the specifics of a customer's journey through our different products, and then making optimal suggestions for them on switching products because it's better for them. So that relates to sort of forecasting, but also different simulation techniques. We do a lot of things in many other domains across the wealth management space and NatWest markets. We look at the trend of the market. So there's a huge variety of things we do. So this is why we recognize the importance of doing this. Was we already knew there was value in data science. We were delivering solutions. We were delivering value. So we were catching fraudsters, increasing revenues, improving customer sort of retention and these things. So we already saw that these metrics could be improved by data science. The problem for us was, how do we keep doing it faster in order to get that value quicker? I can't. I would really struggle. So I sort of sit in a central team who faces off to all of our different domains, our different spokes. But our specific spoke teams, absolutely, and that's what we're working with them now as part of this validation exercise, is to ask exactly those questions. So Faster time to value is the key thing we want to enable, but what is it enabled for you working in the retail banking side or the commercial banking side or in wealth? So it's kind of
understand what the outcome was.
yeah, okay, brilliant. So outcome was those key metrics I outlined, I think. So the faster time to value, the reduced time to spin up. Basically, what we've done is we've provided better capabilities for data scientists like yourselves to do their job. And that's been the key metric driving us. And then it's up to you and your colleagues, your contemporaries to do some of the stuff you've mentioned and drive those specific values for the business. But yeah, no worries. Thanks for the question. Any more? Oh, quick two. Okay, I'm around anyway. You can just come and chat. Thank you so much.